Hello, my name is Brian Bogue, and in this video I will be guiding you through the installation and use of our non-telecentric DHM reconstruction tool using our custom MATLAB application and user interface. So let's get right into it. First thing you're going to need is MATLAB, which can be downloaded from the following link. Next, you will need to download the application from our GitHub page. Once here, press the code button and download zip to the appropriate folder. Now using the MATLAB file browser, we can navigate into the extracted folder. Go to MATLAB GUI folder and install the application into your MATLAB. We can find the application in the apps menu above and click on it to open the application. Now that we are in the application, the first step is to select our hologram. We can do that using the drop-down menu on the left side. Note that the location of the folder is where MATLAB is currently pointing at. Therefore, the holograms that can be loaded from the drop-down menu are the ones in the current directory. We can take a quick tour of the rest of the application. On the left tab, we have all the widgets we will need to reconstruct this hologram. And on the right, we have the plots for each critical step in the reconstruction process. Plot 1 is the hologram, and plot 2 is its spectrum. Now the user will need to supply the wavelength of the light source used to capture the images, as well as the pixel size of the camera used. In the case of these example images, the wavelength used was 532 nanometers, and the pixel size was 5.86 microns squared. Next, we must perform manual filtering of the +1 term in the Fourier spectrum of the hologram. To do this, press the filter +1 term button, and then select the appropriate crop region for the +1 term. Do your best to center the spherical aberration in plot 3, down here. And as we can see, the initial estimates of the size of the +1 term do not fully compensate for the spherical aberration. So at this point, we can try to adjust the size of the crop region to compensate the spherical aberration in plot 4. But this can get kind of tedious since the center keeps changing on us as well. So alternatively, we could use the filter M&N button, which allows us to draw a second rectangle where only the size of the rectangle is recorded and not the position. This can make it easier to do some fine-tuning. Without needing to center the rectangle at all. And in reality can be placed anywhere. But I find it convenient to put it over the -1 term, since they both ought to be the same size. Now, as we get closer and closer, we can see that the background is becoming more and more uniform. And at that point, we've gone too far. And I would say this is a pretty good reconstruction. Alternatively, if you don't want to use the M&N rectangle button, we can instead, let's reset this as best as we can. And we can instead use the sliders on the left. These are fairly sensitive and are always initialized fairly close to the initial rectangle. So you don't have to go very far to try to compensate the background. And so now that's getting pretty close, and I would say that's a pretty good reconstruction right there. We also have the fine-tune G&H button, which allows us to do the manual identification of the center of the spherical aberration in plot 3. But in this case, it did a pretty good job automatically detecting it, so I'm not going to mess with it. And then we also have the option to use minimization for fine-tuning instead. If we look at a different color map, we can see that the background is still not completely uniform. So minimization in this case might be useful. There are a few options for both cost functions and minimization algorithms, but the defaults are recommended. And now if I press run, it'll use the minimization algorithm, which may take some time. Okay, now that minimization is done, you can see the improvements in the uniformity of the background. If this is not obviously apparent, you can use the minimization enable switch to flip between the manual compensation and the automatic compensation. There was slight improvement, so our initial seeds were pretty close. I'll probably go back to grayscale. And finally, there's also the unwrap phase button, which will do just that, but it also can often take a few seconds. So in this case, I don't see any phase wrapping, so I'm not going to use it. And finally, once you're satisfied with the reconstruction, it can be saved to a MATLAB file along with all relevant parameters. Go to the Save tab, and you can optionally change the name of the folder or the name of the file. You can choose to save the minimized phase, which I think it's currently being displayed. No, this one. So if you would want to save both of these or just one. And the same can be done for unwrap phase. In this case, we didn't take one, so I'm going to turn that off. And now export reconstruction.